Hello everybody and welcome. In today's video we are going to be talking about congruent triangles, what exactly that means, the 5 different postulates that lead to us having congruent triangles, and then we are going to close this video out with some proofs. So this is going to be a bit of a longer video, but all the timestamps are in the description. So let's go ahead and get started. So first of all, what exactly does it mean if we have two congruent triangles? Like, let's say we have triangle ABC and triangle DEF, and you're given, we're going to be going over proof. So let's say we are given that triangle ABC is congruent to triangle DEF. What exactly does that mean? What exactly does congruency imply? Well, it implies that all the parts of the two respective triangles have an equal in the other triangle. Or in other words, it would mean that this side matches this side, and that this side matches this one, and the bottom side matches the other bottom side, and this angle matches this angle, etc., 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 all the way around. It means each of the 6 parts of the triangle has an equivalent on the other side, on the other triangle. So if we were given that the two triangles were congruent, and then we were asked to prove something like, I don't know, that side length AB is congruent to side length DE, well, this proof is already pretty much done because we're given that the triangles are congruent. So by the fact that corresponding triangles, so corresponding parts of corresponding triangles are congruent, or CPCTC, congruent parts, congruent triangles are congruent, then AB is congruent to side length DE. So if you wrote this in a statement, reason, proof like table, you know, your 2-column proof, you would have your statement side, and it would be a restatement of the given. Triangle ABC is congruent to triangle DEF. This would be, your reason would be the given. So this is your reason column or your justification column. And then you would say AB is congruent to DE by congruent parts of congruent triangles are congruent. This would be the shortest, easiest proof ever, and you would be so happy that this was the proof on your test. Okay, so let's make it a little bit more complicated. Let's erase this stuff. So it's usually not going to be that easy. I'm not going to say never, but it's usually not that easy where they don't outright tell you that the triangles are congruent. Typically, you're going to have to prove that the triangles are congruent. And so what relationships tell us that our triangles are congruent? Again, congruency between two triangles tell us that all 6 components, all 3 sides, and all 3 angles have a 1-to-1 matchup with the other triangle. So what relationships can allow us to infer that we have congruency? So let's talk about that. So we still have triangle ABC and DEF. So one of these relationships is called side, side, side. And these are all postulates, by the way. These are all postulates. So if you're writing them out in your proof and your teacher is very specific, you're going to want to say, by the side, side, side postulate, I know that triangle ABC is congruent to triangle DEF. So by the side, side, side postulate, and what would that look like? Well, we would know, hey, we would be told that these sides match up, and these sides match up. Okay, and this would tell us that triangle ABC is congruent to triangle DEF. Okay, what's another relationship that we could use? Well, side angle side is another relationship we could use. And what does that look like? Well, instead of being told about all the sides, we would be told one side, then one angle, and then a second side. So one side, an angle, and then a second side. This is what side angle side looks like. And this would also tell us that, hey, triangle ABC is congruent to triangle DEF. Okay. What's another relationship that we could use to show us our triangles are congruent? Another one would look something like this. What if we have, and I'm going to flip it on us a little bit. What if we're told this angle matches this angle? Then we have some side, and then we have another angle. So I kind of shifted some things around. As in this top angle, I had it match this bottom right angle. And that's because I want to talk about naming our triangles. So this relationship is called angle side angle. And we get the name just simply because that's the order we see the relationship in. We see an angle, then a side, and then another angle. This also tells us that our triangles are congruent. However, whenever we name our triangles, it's really important that we name them in the proper order. I've been saying triangle ABC is congruent to DEF, and that's because of how I've been labeling everything so far. But in this example, we would say triangle ABC. Now, it doesn't matter at all how you name your first triangle, but it matters that you're consistent in how you name your second triangle. So here we said ABC. This second triangle, if we're going to be consistent, it would be triangle FDE. It would be triangle ABC is congruent to triangle FDE. And that's just because, hey, we're going to match up, we're going to order our triangle in the order that things match up. Okay, so angle A matches angle F. So that's why we put them in the same ordering. Okay, so I just want to be clear on that. Whereas the naming of your triangle is important and order does matter. So be sure that you're paying attention to that whenever you're naming your own triangles. Okay, we have two more relationships to talk about. Another one is angle, side. It would look something like this, where we have an angle match, another angle match, and then a side that matches. That would be angle, side. And then the last relationship that allows us to know that our triangles are congruent is the hypotenuse leg relationship. Now, the hypotenuse leg relationship, or HL, only appears in right triangles. So it's a given that these are right triangles for the hypotenuse leg relationship. And it's also a given that your hypotenuse are the same and one of the legs of the triangles are also the same. So if you have two sides and it's a right triangle, then that's the hypotenuse leg relationship, and that does imply that your triangles are congruent. Okay? So these 5 are the relationships to look for. Now, which relationships should we also be on the lookout for, but because they don't imply congruency? So let me draw another pair of triangles. Here, let's say we have triangle 1 and triangle 2. And they sure look congruent, but let's say if we're told that all the angles of these triangles are shared. This does not imply congruency. So if you have an angle relationship between your two triangles, this does not imply congruency. Something else that does not imply congruency is if we have a side, another side, and then an angle. Side angle does not imply congruency. This one's easy to remember because backwards it's a foul word, right? And there's no foul language in your math class. So these are the two relationships that do not imply congruency. Again, the 5 relationships we are looking for are side, side, angle, side, angle, side, angle, 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 side, and the hypotenuse leg relationship. All right, so now next, I want us to look at these triangles, look at these shapes, and let us say whether or not the pair of triangles are congruent or not. So let's start top left. Let's check out these triangles. So we're told that we have these markings saying, hey, these sides are the same. So we have 2 sides that are the same. Do we have anything else that will tell us side isn't enough? Do we have an angle or a third side? Well, check out this. The third side is a straight matchup. It's shared exactly. Therefore, these triangles are congruent by the side relationship. Let's check out this triangle. Here might be a little harder to tell, but this angle is matched with this angle. So we have an angle. And then this side matches this side, so we have a side. And then this triangle here tells us what? It tells us that this line is parallel with this line. And put on your thinking caps, does it tell us, does the fact that those lines are parallel, does that tell us anything about our shapes? So I'll give you a moment, pause the video. Okay, yes, it does tell us something about the shapes. It tells us that this angle here is corresponding angle with this angle. Therefore, we have an angle side angle relationship, and these triangles are congruent. What about this pair? For number 3, this pair. What do we have here? Well, we have an angle. We're told that these triangles are right triangles. There's an angle, and we have these sides are matched up. So we have an angle and a side. Do we have anything else? Yes, we do. Yes, we do. We have these pair of vertical angles here, and so we have angle side angle congruency. Continuing forward, number 4. What relationship, if any, do we have here? Well, again, I see 2 sides matching up. And again, we have vertical angles. So that's side angle. No room for foul language in math class. We do not have enough information here to tell us that these triangles are congruent, okay? We don't have enough info. They might be, but they might not be. So not enough information. We cannot tell that those triangles are congruent. What about number 5 here? What do we got? Well, we have an angle marked. These are right angles. And we have a side marked. And then again, just like in that first problem we solved, this middle part is shared. So what do we have? Well, just like the last one, we have side angle. So again, pause the video. Is this one congruent? Yes or no, and why? Okay, unpause. Yes, this is congruent. While it is side angle and there's no room for foul language in math class, this is a right triangle. So that means the shared line is the hypotenuse, and we're also told that one of the legs are congruent. So by the hypotenuse leg relationship, these two triangles are congruent with one another. Okay, let's check out these two. So here, again, the middle line is shared. We have an angle, a side, and an angle. So by angle, side, angle, these two triangles are congruent. And lastly, here again we have a shared side. And so by angle, angle, side, these triangles are congruent. Excellent, excellent work. Excellent work. So as we go forward, let us get to some proofs. So this first proof is given that W or YW bisects angle XYZ and YW is perpendicular to XZ, prove that the two triangles are congruent. Okay, so before I even begin this proof, I want us to talk a little bit how we can structure our proof so that proofs aren't so daunting. Okay, so the 2-column proof system is what you're doing in your math class most likely, and that's where you have a statement side and you have a reason side. Okay, so and then you kind of make a tree and you fill in your proof. So your first statement is always going to be the given. It's always going to be to restate the given. So we have YW, segment YW, bisects angle XYZ, bisects angle XYZ. And what else do we have? We have YW is perpendicular to XZ, line segment XZ. So this is a restatement of our given. Okay, so the first step is just to restate your given. The second step is going to be the consequence or the repercussion of your given. Okay, so let's look at what was our given? It was that YW bisects some angle. YW bisects some angle, that angle is XYZ. What's the repercussion of having a bisector? Well, that means that this angle and this angle are congruent. So we would say angle XYW is congruent to angle ZYW, and our reason would be the definition of an angle bisector. And again, we came to this just because it was a repercussion of our given. Our given told us that we had a bisector. What does that mean? Well, that's going to be our second statement. Okay? What else are we told? We're told that we have a pair of perpendicular lines. Okay? So this is another part of the given. So what's a repercussion of having perpendicular lines? Well, if YW and XZ are perpendicular, then that means that angle XWY and angle Y, or rather ZWY, are right angles. And this is by the definition of perpendicular lines. So we just said that these two angles are right angles by definition of perpendicular lines. If they're right angles, then that means what? So our process for proofs is restate the given. Then our next process is to say what is the repercussion of our given. We are able to say, well, our given, we have an angled bisector. So our next step is the definition of an angled bisector. And then we're also in our given told that we have a pair of perpendicular lines. So what's the repercussion of that? Well, the repercussion is that we have a pair of right angles by the definition of perpendicular lines. So what will be next? What follows is going to be the repercussion of our repercussion, if there is any. And I know that kind of gets a little meta, but number 4 is going to be that these angles, angle XYW is congruent to angle ZYW, and that's just because of the right angle theorem. And the right angle theorem, if you don't remember, is just that all right angles are congruent to one another. So this is what we have so far. And the last couple of steps for these proofs, especially since we're doing triangle congruency proofs, we want to see how they're going to relate back to one of those 5 postulates. Okay, and what do we have in this example so far? Well, we have 2 angles, so we need to figure out, hey, is there anything to do with one of the sides in this triangle? Because we know angle won't work, so we're looking for a side. And hey, yeah, this middle side, this middle YW is shared between both of the triangles. So our 5th step will be that YW is congruent to YW, and that's by the reflexive property. And then now, what do we have? Well, we have an angle, and a side. And so, and in the order, what is this? What is this order? This is angle, side, angle. And so by angle, side, angle postulate, we can say that the triangles are congruent. So triangle, and let's rewrite the order as it says, triangle XYW, triangle XYW is congruent to triangle ZYW, is congruent to triangle ZYW, and the reason is because of angle, side, angle postulate. Excellent. Here, let me scroll down so you can see that last bit of work. So again, let's go through the process before we go on to another proof. We restate the given. Then we say the consequence of said given. Then we say the consequence of our consequence if we have one. But more exactly, we will think of how can we relate what we have to one of the 5 triangle postulates that allow for congruency. And then once we have that relationship, we can say that the triangles are congruent. Excellent. So the next question is, given that angle 1 is congruent to angle 2 and B is the midpoint of AC and BD bisects angle ABE and BE bisects angle DBC, prove AD is congruent to CE. Okay, before I even get started on this proof, let's go back. I want to mention some of the justifications, the common justifications that you may see whenever you are doing these proofs, especially with triangle congruence. So a common one you could see is some definitions. So here let's list some definitions. We can see the definitions or definition of congruence. The definition of congruence is simply that, hey, if one segment is congruent to another segment, then that means their measures are equal as well. You could see the definition of a midpoint. Now, what is a midpoint? A midpoint is, hey, if we have a line and this point is the midpoint, well, that would imply that this distance is equal to that distance. That's what midpoint means. Okay. What else could we have? Well, we could have the definition of an angle bisector. What's an angle bisector? Well, given some angle, if you have an angle bisector, that means it cuts the angle in half. So these two parts would be equivalent to one another. That's the definition of an angle bisector. Some other things that we have are properties. And I know teachers are really particular about naming everything properly. Is it a definition, a property, a theorem, a postulate, yada, yada, yada. So some common properties are, your addition, your subtraction, your multiplication, and your division properties. These are all properties. Another property is the reflexive property. And technically there's two reflexive properties. There's the reflexive property of congruence and the reflexive property of equality. And the of congruence would be if you're talking about a side length, and a reflexive property of equality would be like if you had 4 equals 4. Okay, this is what reflexive property is. Reflexive property of a side length would be like what we had down here in this proof, where the side was the exact same thing for both triangles. It was literally the same line. And so on reason 5, we said YW is congruent to YW by the reflective property. Okay, so that is an example of reflective property. Okay, some other things we have are theorems. We have theorems. And some theorems include, the right angle theorem. The right angle theorem, that just says that all right angles are congruent to other right angles. We used that in our last proof. We have the vertical angle theorem. The vertical angle theorem is, like if we have two lines that are crossing, the lines kind of vertical to one another or directly across from one another, those are congruent. That's true by the vertical angle theorem. Now, if we're dealing with parallel lines, recall that if we have some parallel lines present and we have some transcendental line, then we have things like alternate interior angles. Well, here are alternate interior angles. So the alternate interior angle theorem tells us that those angles are congruent. We would have the same side interior angles. That tells us that our angles are supplementary. And we have that for interior and exterior angles. We also have the corresponding angle theorem. Those are all examples of things that we can use in our proofs. So with that, let's continue onward. Let's continue to our next proof. So let's see what this says again. So given that angle 1 is congruent to angle 2, so I'm going to mark it. So angle 1 is congruent to angle 2, and B is the midpoint of AC. So B is the midpoint of AC, and BD, so this line, BD bisects angle ABE. So BD is a bisector for this part, and BE bisects DBC. Okay, so BE is a bisector for this part. We want to prove that side AD, so we want to prove that this side is congruent to CE. So we want to prove that the far left-hand side is congruent to the far right-hand side. So how are we going to do this? Well, let's start with our two columns. We have our statement and justification columns. Sometimes justification is called reason, sometimes it's called justification. So you might see me flip back and forth between the two labels. Okay, just like we did in the last proof, our first statement is always to restate the given. So we have angle 1 is congruent to angle 2. We have B is the midpoint. B is the midpoint of AC. And we have BD bisects angle ABE. We have BD bisects angle ABE. And BE bisects angle DBC. Okay, and this is all just the given. Okay, I might have to erase this if I run out of room, because that's a lot to rewrite just for the given. But let's just continue onward. So what can we learn? So after we write the given, we go to the repercussions of our given. So we are just told outright that angle 1 and 2 are congruent. There's not too much we can... Well, what is the repercussion of angle 1 and angle 2 being congruent? So this isn't something I said up there in our reasons, but one more theorem I should have mentioned is of course, the isosceles triangle theorem, or the equilateral triangle theorem. And if you know what an isosceles triangle or an equilateral triangle are, you pretty much know what these theorems are. But the isosceles triangle theorem just states that, hey, if within a triangle you have two angles that are equivalent, well, then that means you have an isosceles triangle. And by the definition of isosceles triangle, the sides opposite of it are equal, are congruent. Okay? So the repercussion of angle 1 and angle 2 being congruent is that triangle DEB is isosceles. And that's by the isosceles triangle theorem. And then what's the repercussion of triangle DEB being isosceles? Well, that means side length DB is going to be congruent to length EB. And this is really all under one step. This is all from the isosceles triangle theorem. Okay? So we know that these two sides are going to be equal because this is an isosceles triangle. What else are we told? We're told that what else were we told from the given? We're told that B is the midpoint of AC. We're told B is the midpoint of AC. Well, that means... What does that mean? Well, that means that AB is congruent to BC. And that's by the definition of midpoint. By the definition of midpoint, these two sides are the same. Okay, and then what lastly were we told? Well, we were told that BD bisects ABE. Well, if BD, this line here, bisects ABE, this full angle, then that means what? That means that angle 3 and 4 are equivalent. So angle 3 is congruent to angle 4 by definition of angle bisector. And what else? Well, also in the given, we are told that CB, or rather that DBC is bisected by BE, and so we know that 4 and 5 are also equivalent. So we know that angle 4 is equivalent to angle 5. And this is also by the definition of angle bisector. So we know that angle 3, 4, and 5 are all equal. Now we haven't outright said yet that 3 is congruent to 5, but of course we can. So we know that angle 3 is congruent to angle 5 by the transitive property. And then what can we say? Well, hey, check this out. Now we have an angle matchup, and we have a side length here and a side length here. So by side angle side postulate, we can say that our triangle on the left is congruent to our triangle on the right. And then because congruent parts of congruent triangles are congruent, we can say that AD is congruent to CE. So let's write those last two lines. Here we kind of ran out of space, and I can see that I'm in the way. So here I'll write the last two lines over here. The last two lines over here are that triangle ABD is congruent to triangle CBE, and the justification is by side angle side. And then lastly, part 8, we know that side length AD is congruent to side length CE because congruent parts of congruent triangles are congruent. So let's have a refresh. Let's run through this problem one more time so you can see exactly what happened. So firstly, we restated the given where that angle 1 is congruent to angle 2, that B was the midpoint of AC, and that BD bisected angle 3 and angle 4, and BE bisected angle 4 and angle 5. Next, we were able to say, well, hey, since angle 1 and 2 are congruent by the isosceles triangle theorem, we know that this middle triangle is isosceles. So the legs, the sides opposite the angles, are going to be congruent. Next, we were able to say that AB is equal to BC by the definition of midpoint. By the definition of midpoint, we were able to say that. That was number 3. Number 4, we were able to say that angle 3 is to angle 4 by definition of angle bisector. Same thing with number 5, that angle 4 is to angle 5 by definition of angle bisector. Number 6, we're able to say that angle 3 is to angle 5 by the transitive property. Therefore, we know that by side angle side, our left-hand triangle and our right-hand triangle are congruent. And then because our triangles are congruent, these two segments of our triangle are congruent. And that's again by CPCTC, which is congruent parts of congruent triangles are congruent. Excellent. Let's continue forward. Let's look at this one. Given PQ is perpendicular to QS, and TS is perpendicular to QS, and R is the midpoint of QS, prove that R is the midpoint of PT. Okay, so here we have, and I'm going to move myself to the other side of the screen so I don't get in anybody's way of seeing exactly what's happening. If you made it this far in the video, let me know down in the comments below. Also, there's lots of ways to solve a proof. So if you found a different way, let me know that in the comments below as well. Again, thank you all for being here so much. It really means a lot to me. Hit that subscribe button. Thank you, thank you, thank you. Let's get to this proof. Again, the first statement is always just a restatement of the given. Now, in order to save space, I'm just going to put quotes around this, and I'm just going to put quotes here. I want this to be clean so we know exactly what's happening. So firstly, we're just going to restate the given. Next, we're going to say what is the consequence of our given. So what were we told in the given? We're told that PQ is perpendicular to QS. Okay. So that implies that that's a right angle. So we know that angle PQR is right. And then what else do we know? We know that TS, and we know that this angle is also right because TS is perpendicular to QS as well. So we're also going to say angle TSR is right. And this is simply by the definition of perpendicular lines. Okay. Now, what's the repercussion of having a couple of right angles? Well, the repercussion is that these two angles are equivalent. So we would say that angle PQR is congruent to angle TSR. And this is by the right angle theorem. Okay, so we've officially said that these two right angles are congruent. Excellent. Let's go back up to our given. What does our given also tell us? It says that R is the midpoint of QS. So next we can say that, hey, segment QR is congruent to segment RS, and that's by the definition of midpoint. What else can we say? So we know that these lines match up. What else can we say? So we've used what's in our given. Now we need to ask ourselves, okay, what do we have? Can our picture give us anything more? And also remember what you're searching for. We're doing proofs on congruent triangles, so you're always looking to get to one of those 5 postulates. Okay? We're looking to get to one of the 5 postulates. We have an angle and we have a side. So we need either another angle or a side. And hey, looking to our picture, I can say, oh, we have a pair of vertical angles here. So I'm going to say for number 5 that angle PRQ is congruent to angle SRT by the vertical angle theorem. And then next, now what do I got? I have angle side angle. And so 6, I can say triangle PQR is congruent to triangle TSR by side angle, by angle side angle postulate. And because of that, I can say that PR, because my triangles are congruent, that means the parts of my triangles are congruent. What am I searching for in this proof? I'm searching to prove that R is the midpoint of P and T. So I'm not quite there yet, but I can say that PR is congruent to RT because congruent parts of congruent triangles are congruent. And then I can say that R is the midpoint of PT. And I can say this by the definition of midpoint. Excellent. Then I don't know about you guys, but this is just so satisfying for me to just finish a hard proof, get it all there, get it all down. It's just so satisfying. Let's go on. We have 2 more proofs left. 2 more proofs. Let's keep up the grind. Excellent work, guys. Give yourself a pat on the back if you made it this far. Super, super proud of all of you. Okay, here we have the given that VO is congruent to RO and that X is parallel to Y. Okay. We have VO, so we have our statement. And we have our reasons. So our first line, our number 1 is always to restate the given. So VO is congruent to RO and X is parallel to Y. Oops, I said equals, meant parallel. X is parallel to Y, and this is our given. So what does this tell us? Well, VO is to RO. So that means this side matches that side. Okay. So that was just a given. One of the sides matches. So X and Y being parallel, what does that tell us? So let's label these lines to be parallel. Well, if these lines are parallel, then either of the other 2 lines in questions can be seen as a transcendental line. So that means that I can say that this angle and this angle are what? Well, they're alternate interior angles. So I can say for number 2, I can say that angle, here we'll call it RPO, angle RPO is congruent to angle VEO by alternate interior angles theorem. Excellent. And then also, what do I got here? I got a vertical angle. We can say that angle POR is congruent to angle VOE by vertical angle theorem. And so I have an angle, and I have a side. So by angle, side, I know that triangle PRO is congruent to triangle EVO. Done and done. It's that easy, guys. Excellent, excellent, excellent. We're on to the last proof. On to the last one. Okay, what do we got here? What do we got? We have given HE, given that HE is congruent to RO and angle THO is congruent to angle MER and TO is parallel to MR. We want to prove that TO is parallel to MR. Okay, we got a lot going on here. So we got our statement. We got our statement and we got our reasons or our justifications. So let's draw our little line down the center for our 2-column proofs. And I challenge you guys, pause the video right now, see if you can do this proof on your own, and then come back after you're done and see how you did. So first of all, we're going to restate the given. So we have HE is congruent to RO. And we have angle THO is congruent to angle MER, and we have TO is parallel to MR. And this is all the given. Excellent. So our next step in the process is to think of the repercussions of our given. So we're told HE is congruent to RO. So what does that tell us? That tells us that this little bit here is congruent to this little bit here. Okay. So I'm gonna think out loud right now. Okay. Part of proof writing is just thinking about how you're going to get there, and then the other part of proof writing is once you think it through, you just have to figure out how to put it all together. Okay, so let's talk this through. Okay, if we're told that HE and OR are congruent, then I know that the full side length HO and the full side length ER are also going to be congruent because they have this shared overlap of EO. Now I just need to think, okay, how am I going to write my proof in order to incorporate that part? Okay, well, I need to add that EO segment to both of my other segments, and then I need to show that they are equivalent. And so to do this, I'm going to be adding stuff. So you don't add segments, you add measurements. So my next step, here I'll go back to white. My next step is I'm going to say that HE equals RO, and this is true by the definition of congruence. So before we knew that the segments were equal. Now I'm saying that the measures of the segments are equal. Now I'm going to say that, hey, if we add we can add OE to both of these sides. So I'm going to say HE plus EO is going to be equal to RO plus EO. All I did was add EO to both sides, and I'm allowed to do that by the addition property. Now, what can I say? Well, this is equal. Where to go to from here? Well, we know that this is equal to HO, and this is equal to RE. So HO is equal to RE, and that's true by the segment addition postulate. Segment addition postulate. Okay. And now I'll just say that RE is, I wrote it backwards, but HO is congruent to RE, again, by the definition of congruence. You do this full loop around. Definition of congruence. Okay, so I did this full workaround in order to get that HO is congruent to RE. So notice how I needed to use the definition of congruence to strip the fact that we're talking about the fact that these are lines, and use just the measurements, and then I was able to add OH, and then by the segment addition postulate and the definition of congruence, we're able to regroup and say that, hey, segment OH is congruent to segment RE. Now that we have that, So that was steps 3 and 4. Now that we have that, where can we go from here? Well, what else did our given tell us? Our given also told us that angle THO, so this top angle, is congruent to angle MER, this angle here. Okay, that's very nice. Really not much to go from that. But what else are we told? Well, we're told that TO is parallel to MR. So these lines are parallel. And what does that tell us? Well, since these lines are parallel, this backstop can be thought as a transcendental. Therefore, this angle and this angle are corresponding angles. So we can say that angle MRE is congruent to angle TOH by corresponding angle theorem. And then what do we have? What do we have from here? Well, we have an angle, a second angle, and we have a side. In what order do we have it in? We have angle, side, angle. So we can say that our two triangles are congruent. Yes, we can say that triangle THO is congruent to triangle MER by the angle, side, angle postulate. Now, exactly what were we trying to prove here? We're trying to prove that TO is congruent to MR. Well, we can say that now. We can say that segment TO is congruent to segment MR. Why? Because congruent parts of congruent triangles are congruent. Bam, bam. Thank you, ma'am. This proof is done. Excellent work, everybody. Thank you so much for joining me for this video. If you found it helpful, hit that like button and hit that subscribe button, and I'll see you in the next one.